I'm one of the network guys, as you can guess by the t-shirt. So hopefully the network was working okay. And how a networking guy can talk about a networking protocol at an application developers conference. Well, add this protocol into a cool application and then talk about it, and talk about both. So we will start talking about the Mongrel2. If the slides go and change. Okay. So Mongrel2, first of all, is really a Lego building block for building your web applications. So you have clients coming in on the front end, connecting via normal HTTP requests, or if you do the things like web chat, you can do long polling, or you can have the Flash applications on the client side connecting to the Mongrel2 using the Flash sockets. And what Mongrel2 does is that it converts those requests on the backend into the ZeroMQ messages. And you connect your backend handlers via ZeroMQ to the Mongrel frontend. So what this gives you is very much flexibility and language agnosticism. So you don't care which language your backend is written in. So the Mongrel is very much language agnostic in this case. Now, it obviously also handles the static files and the reverse proxy. Manageability of Mongrel2 is also a very interesting thing. It has its configuration embedded into the SQLite3 database. So why that? That means that you can not only use the built-in M2SH, so Mongrel shell that is used to control the operation of Mongrel2, to convert the standard text configs into SQLite3, but you can also use your own configuration database, and then you can integrate SQLite3 that Mongrel2 uses together with your configuration backend. Another interesting thing is that you can use the Rails-like routing, so you specify which handle attaches to which URL subtree. So think of it like mounting of the volumes under any of the Unix operating systems. Efficiency. So how many people in the room worked with the Mongrel, with the previous generation thing? Okay, a few. What Mongrel and Mongrel2 have in common is the skeleton. So the skeleton is the Ragel-made parser for the HTTP protocol, and it's formally generated code from the description of the HTTP protocol taken from the RFC. So as a result, the performance of this parser is quite good. And also the number of bugs that you create when you make the code manually is also much lower. So you have automatically generated parser. And this gives both the performance and the strictness of the parsing. On the back end, at the same time, we have ZeroMQ. So ZeroMQ is very lightweight messaging library. And using this library, again, allows to abstract from any language, any kind of protocol that is used to signal with the backend. Because with ZeroMQ, if you were, I think there is another lightning talk on ZeroMQ library itself, and you can see there that the number of languages that the library supports is astounding. So there is probably 15 to 20 languages that it supports. So that's a really good thing. Now, for me, I wanted to have a great web server to use that would support IPv6. So Mongrel2 was perfect candidate with one detail that it didn't support IPv6. So I started digging into the code and looking how the networking part is implemented. And the networking part is implemented as part of libtask, which is really a task library by Ruth Cox. And the abstractions that are in that library are really pleasant to work with. So effectively, you don't need to work with these one-time use structures where you take the name, then you convert it into the structure, and then you just use that structure once. So all of that is abstracted inside the library. So effectively, there are three primitives that are there that you need to work with. It's announce the socket, then start connecting to a client or a server, and accept the incoming connections. So this provides an abstraction layer from the rest of the code. And How to add IPv6? There's plenty of documentation on the web, so I just picked one of them, which shows the example of code before porting to IPv6 and after porting IPv6 support. So I basically just went through the same logic as was there. Obviously, what I showed in the previous slide, this very nice level of abstraction also gave very few changes in other places in the system. So there was only one place to change in the remaining part of the code of Mongrel2, which is kind of giving an impression of the niceness of the quality of the code base. Another assumption that I made was that bind v6 only variable is set to 0. So we'll talk a little bit about that variable later on. Now, after I made this code, then we shipped the Mongrel2 with the support, and there came some interesting problems. So first of all, get address info is not cached. So when we use it in a reverse proxy and the configuration specifies the target by name, then per connection attempt to the backend server, we have at least one DNS request. Well, in reality, it's two packets, the IPv4 and IPv6 resolution attempt. So that's not very performant if you have DNS server a couple of hops away. So you would either put the DNS server closer, or maybe in the future we will change the logic a little bit by adding the local cache. Now, another interesting point that I heard is that some people at this day don't have the kernels with IPv6 enabled at all. So my optimistic assumption that, hey, well, if INET6 socket will be just created, it failed. And finally, which is not specific to IPv6, was the increased latency in serving the request, because there is no non-blocking name resolution interface in the socket library. So for the users who don't have IPv6 in the kernel, basically Zed came up with an interesting hack where you explicitly specify the bind address. So if you specify the v4 wildcard bind address, then you bind only to v4 address family. And then you work around this fact that some people don't have the v6 support in their kernel. Or if you're ready, when you're ready to deploy v6, then you can just change that variable to : which is the wildcard for IPv6 address, and then you can bind your server to IPv6 socket. Now, a little bit of rant about having to deal with two address families is that INET M2P is not really suited for printing out the socket addresses, because it deals with the address as itself, whereas in the code you mainly deal with the socket structure, where you have the address and the port. So then you need to have a little bit of this kind of slightly spaghetti code that has if family is 4, then do this, or if family is 6, then do that, which is a bit of inconvenience, because I would expect every program would need to have this kind of operation. Now, remember I mentioned the single socket, so the bind v6 only. It's a very interesting feature where you are able to port your v4 applications, in my opinion, much easier, because you had one socket before and you still have only one socket afterwards. It's just that this socket can handle both v4 and v6 addresses kind of magically. So your previous v4 space gets mapped into v4 mapped addresses on this socket. So on the other hand, there are different opinions. So this was my opinion from the implementation point of view. There are other implementers who may have other opinions. And this setting had an interesting history. It was first on, then off, and finally now it's again on in the Linux by default. But in BSD it's off by default. Another interesting problem is address family selection. So it was not really big problem, I think, for the Mongrel2 code per se, because normally the scenario that where we use the name resolution as a client imply that we have both the backend server and Mongrel2 as a client. So in this case, both hosts are in the same administrative domain, so you can fix if something is broken. But if you are developing applications that are only client-side, and if you have the applications that require the real-time user response, then you probably would need to deal with it somehow less relaxed manner, I would say, than RFC 3484 specifies, because 3484 just says, okay, you first select v6, and then you start going by the addresses you get from get address info. So for that, me and one of my colleagues, we had a small internet draft on the idea of how to do the address selection. And also, very recently, Mark Andrews from ISC, he published a blog post where he specifies a different algorithm, but probably more efficient than ours, where he bounds the connection time by fixed interval. Now, obviously, all of these cool things for user experience are not to replace fixing the brokenness. Finally, a few conclusions that I've taken for myself from this Mongrel2 IPv6 exercise is that, well, first, Mongrel2 is really awesome application. So if you don't hack on anything open source, I would really invite you to start playing with it and use it in your project. By the way, the stats for the network, so if you looked at the stats for the network at fosdem.stdio.be, so that's my domain, they were served from Mongrel2. So I'm not going to demo it because we were demoing it for the past 1.5 days. And really, adding v6 in itself is not that much of a big deal, but tuning it and making sure that it works correctly for all the users, that's something that needs some time. So really, if you have your application that doesn't support v6, then you would really want to start now and start to exchange opinions on how things work better. So with this, I would like to thank you and open for questions, if any. Yes, there are thoughts to add the non-blocking DNS, but so the question was, are there thoughts to add the non-blocking DNS? There are thoughts, and we've been trying very hard to find the asynchronous DNS resolver library that, well, to state it politically correct, that would work. Because the existing ones are interfering very heavily with the green threads that are used in the Mongrel2, because they basically either start threads, or they fork a process, or they do some other weird things from just underneath your back. So I have some very, very initial code, but it's not yet the async resolver as such. Thanks. So performance benchmarks, the get address info is something that is really hurting quite a lot. So in terms of pure static files, I think I don't have the exact data, but I think they should be pretty much the same. So protocol-wise, there is not a whole lot of overhead, and code-wise, the paths, as I said, they are very, very similar. So basically, we use the exact same socket code for v4 and v6, with the only difference that this part is one of the few places where it's different. So otherwise, it's exactly the same code.
Okay.
So yeah,
No more
questions.
Thank you very much for the presentation.